Hello, I'm Deniz Sönmez. I'm from Mechanical Engineering Department, and today we'll be conducting an experiment in order to find the spring constant. The equipment we'll be using, as you can see, is a ruler, two 100-gram weight, 150-gram weight, a hanger, a spring, and a chronometer. The first part, in order to conduct the first part of our experiment, we need to first hang our string like this, and hanger beneath the spring like this. And since the formula we'll be using is F equals K times delta X, we'll be looking for the change in the length of the spring. Firstly, we take the initial length of the spring before we put anything on it. And after we take note of the measurement, we are ready to put our first weight on the hanger. And as you can see, the length of the spring has increased, and now the spring is about 3 centimeters longer. So by using F equals K times delta X, we can find the K. But since one experiment isn't enough to get a realistic result, we should do it multiple times with different weights. This is now 200 grams. And yes, the spring has increased by about 6 centimeters. By using these results, we are able to find the K constant in the spring for the first part. To conduct the second part of the experiment, first we need to use the formula T equals 2 pi square root of M over K. The T here is the period of this oscillation motion, and we will measure this with the chronometer. And as you can see, I put a 200-gram weight on the hanger, and we just we just measured the period of the motion, and same as the first part. To get a more realistic result, we should do it with multiple weights, like different kind of weights. We expect as the weight increases, the period to increase. So by using the formula T equals 2 pi square root of M over K, we can find the K, the spring constant, and compare the spring constants between the part 1 and part 2. And to finalize our experiment, we need to find the difference and calculate the error percentage of the two.